Okay, this week the focus in math is to be able to compare fractions um, with different numerators and different denominators. And one of the learning targets that we're asking the students to meet is that they can use symbols, the greater than, less than symbol, or the equal sign to compare fractions with the same denominator and different numerators. We're also asking them to recognize that fractions with different denominators and the same numerator represent different values. Also, we're asking them to use benchmark fractions to compare fractions, and then that we can only compare two fractions that refer to the same whole. So this video is hopefully going to address all four of those things. And the first way, there's a couple of ways that the students are being asked to do this. They can first of all model it, and so one of the problems we looked at today was if we had 2/4 and 2/5, which one is greater? And so in the book it was actually a problem about granola bars, and so the granola bars had to be the same size, and each of the characters in the problem ate 2 pieces of the granola bar. So the book draws a model, and so I've been teaching the kids you can draw a rectangle, and you actually have to draw 2 of them, but they need to be the same size. And I know it won't be perfect, but you have to try your best to try to make them perfect. The first one's going to have 4 sections, so if I draw 3 lines, and you want to try to make your parts equal, and we know that this one has 2 parts shaded, and then this one also has 2 parts shaded, but in this one we're going to have 5 parts. And so if we shade 2 of these, so my model isn't very great because if you look at the end 2 sections, this is kind of bugging me here. Those 2 lines shouldn't match up like that. And so if I kind of fix this one too. So sometimes it's kind of hard, especially on this iPad, to draw perfect sections, but your model should look something like that. So the students should be able to say, okay, these holes are the same size. The fifths are smaller than fourths, and so I know that 2/4 is greater than 2/5. The book also gave an example where their models were a little bit different. So if you had the fourths model is still the same, but then the other character ate a granola bar that was a different size, we can't compare those 2 fractions. So if this was the granola bar of the other character, and we had this split into 5 sections, then this 2/5 would be bigger than that 2/4, but they aren't the same size whole, so we cannot compare those 2 things. I'm going to bring up another example, one that was pretty good. One thing that we looked at is that if fractions have a different denominator but they have the same numerator, actually I won't bring up a different fraction, this one works for this. So we kind of already talked about it, but if this denominator is bigger right here, that means I have smaller pieces. this denominator is a smaller number, so I have bigger pieces. If I have the same number of pieces in each fraction, I know that this is going to be larger because the pieces are larger. One of the other examples today that the students had was a very obvious one. So it was kind of fun to do and see if they would recognize it. They had 2/3 compared to 1/5. And so for this one, the kids could make a model, but they don't need to, because I know that one of these pieces over here is smaller than one of these pieces over here, and I actually have two instead of one piece, so then 2/3 is clearly bigger than 1/5. But if we did draw our model, it would look something like this. Shade in 2/3. I would draw my same rectangle, same hole, but this one has 5 pieces. And so clearly you can see one of these pieces here is smaller than one of those pieces here, and I have 2 of them. One of the other ways we learned today to find equivalent fractions is to compare fractions is to use equivalent fractions. And so if I take an example that we had today, I had 3/4 and I had 7/8. So if I take 3/4, I know I can turn fourths into eighths, so I can actually go and do 4 times 2 equals 8, and whatever I do to the denominator I must do to the numerator, so I multiply that by 2, and that's 6/8. And I know 6/8 is smaller than 7/8, and since 6/8 is the same as 3/4, then 7/8 is greater than 3/4. The other thing we can do is, if our two fractions are different, if I go back to the fraction I just had, I had I had 1/5 and 2/3, so 2/3 and 1/5. So I know that 3 and 5 can have a common multiple of 15. So if I multiply 3, so I would take 2/3, and if I multiply 3 times 5, I can get 15. I do the same to my numerator. 2 times 5 is 10. So 10/15 and 2/3 is the same. If I take 1/5 and multiply it by thirds, or threes, 5 times 3 is 15, and 1 times 3 is 3, so I can compare 3/15 and 10/15. I know 10/15 is greater than 3/15, so since 10/15 and 2/3 are the same, then I know 2/3 is greater than 1/5 because of equivalent fractions. And there's one last way that we can take and compare fractions, and that's to use a benchmark fraction. So use a fraction that you know, like 1/2. It doesn't always have to be 1/2. It can be 3/4. It can be 1 whole. It can be thirds. The thirds are easy to remember. So anything that you can use as a benchmark. And so this is what it looks like. So if I have if I have 3/8 and I have 5/8, I know a benchmark fraction would be 1/2, or in this case 4/8. So if I know that 3/8 is less than 1/2 and 5/8 is greater than 1/2, so I would know that that's the case. Also, it would work in this way. If I had 3/8 and I had 4/6, so now I have different denominators, so I can't compare them right away, but if I use a benchmark fraction, so I use 1/2, I know that 3/6 would be 1/2 using 6, and 4/8 would be 1/2 using 8. So 3/8 is less than 1/2 and 4/6 is greater than 1/2. So these are the different ways that students are using to compare fractions. Hopefully this helps out this week.